For today's project, my project was resistance in parallel. As you can see, the founder of resistance in parallel was George Simon Ohm. He was born in 1789 and died in the year of 1854. He was a German physicist and a mathematician, and is the founder of resistance in parallel. As you can see, resistance in parallel is a fundamental concept in electrical engineering that describes how electrical engineering how electric current behaves when it has multiple paths to flow through, unlike series circuit where components are arranged sequentially. A parallel circuit involves connecting resistors or any electrical loads such that their terminals are connected to the same two nodes. As you can see here, in this paragraph, I explained that there are three light bulbs here. Even if one is not working, as you can see, one is not working, but the others two are still working. This is the benefit of resistance in parallel. Whereas resistance in series, if one does not work, then the others does not work. Because in resistance in parallel, the wires are connected with the same battery, yet they
individually.
Yet they individually work on their own. This arrangement caused the total resistance of the circuit to decrease as more components are added, acting in a way that is often intended to think of as increasing lanes on a highway. Core principles of parallel resistance. When resistors are connected in parallel, they obey two primary rules that define their behavior. The first primary rule is uniform voltage. The voltage across each resistor in a parallel branch is exactly the same. Since all components are connected directly to the same two nodes, they all experience the same potential difference. And the second primary rule is divided current. The total current from the source is divided among the branches. The sum of the currents through equals the total current entering the parallel network. Next point is why total resistance decreases. This is a questionable question which some may have curiosity about. The answer is that the defining characteristics of parallel resistance is that the total equivalent resistance is always less than the smallest individual resistor in the combination. This may seem counterintuitive, but it occurs because each adds resistors provides an additional path for electric charge to flow. For an example of the benefit of resistance in parallel is, think of a busy store with only one checkout line. If you add a second checkout line that is also a parallel branch, the overall resistance to customer flow decreases, and more customers can pass through per minute even if the new line is slow. In this particular paragraph, it is a simple example of resistance in parallel. In a shop, there's only one counter, and if there's only one counter and there are lots of customers, the queue will be long, and it is a big disadvantage to people. But if there are two or three more counters in a busy store or market, the customers will divide into three or more queues, therefore benefiting the store and also the people. Next is laws of combination of resistance in parallel. Point A is the reciprocal of the combined resistance of any number of resistors connected in parallel is equal to the sum of the reciprocal of all the resistances. these 3 points A, B, C, I have taken it from the textbook. If you can see, you guys can look it up if you want to. The the the, the second point B is the potential difference across each individual resistor remains same irrespective of the values of the resistors. The C point is the current flowing through each of the resistors is inversely proportional to the value of resistance. The construction of a resistance in parallel is actually very simple if you know how to build it. First is the preparation. Use a headboard or breadboard style terminals to securely connect to resistors, leads, reducing contact resistance. Like this one, right here. It may look ugly from the back side. It may look ugly. It may look untidy from the back side, but it works properly. Except this one, since it burned out. Well, like I particularly use a cardboard because it is easier to trim it up if there's any extra pieces. And second point is connection. Connect all left side leads of the resistors to positive and all leads to negative. Unfortunately, I don't know where the battery of positive or negative is, but we have to connect the wires with the batteries. After that, circuit integration. Place this parallel combination in series with power supply, an ammeter to measure total current, and a plug. A plug can also be a button or a switch. As you can see here, I used a particular switch, and I have lined the bulbs in series, and I have connected it with a battery, and button, and I connected it with a battery. Here you can see, even though there are three different wires, I have connected it here, and then I connected it here again. And the last is the earlier construction was from Google, and the materials I'm about to say is what I had used. Requirements is 3 or 2 LED bulbs, cardboard or any flat large object to work on, and switch, connecting wires, AAA battery or any strong battery, black tape, hot glue, and other electric tools you may need. Thank you, LVO.